Hi there, welcome to today's episode. Today we are joined by Carringtone Kinyanjui.
Pleasure to be here.
Yes. Carringtone Kinyanjui is a Ph.D. student at the University of Manchester, where he studies the intricacies and the insights that we can get in social networks using natural language processing. Carringtone, can you tell us what natural language processing is?
Hi Roger, thank you for having me. When we want computers to understand language, what can we do? What should we do? As some of your listeners, or maybe all, maybe you have an interesting crowd of listeners, computers only understand numbers, ones and zeros, and derivatives of ones and zeros. So you need to find a way of turning words, sentences, paragraphs into numbers. And how you do that is to basically assign unique numbers to each word, each phrase, and to see how the pattern of numbers emerges. And the hope here is that the pattern of numbers will mimic or at least have some representation of the pattern of language. And the process of doing this, the process of getting machines, computers to try and understand language is the field of natural language processing.
Fantastic. So, as you can already tell, Mr. Carringtone is very good at explanations. So he's he's not wasting this skill. He's not wasting it at all. Yes, when you see him sit here, he's not just learning his PhD thesis. He's actually teaching people a lot about machine learning and about artificial intelligence. So I first met Carringtone at hackathon at the Technical University of Kenya. The Technical University of Kenya, where we did a hackathon together. And that is the first time that I saw him actually teach people about machine learning, and it was great to see. Now, not too long ago, what was it, two weeks?
This was 2 weeks ago.
Yes. 2 weeks ago, he invited me for yet another similar initiative.
Yeah.
So this one is run by a program that he founded called the Kisima Library Project. The Kisima Library Project. So, Carringtone, will you tell us a little bit about the Kisima Library Project?
So, I am a product of towns and cities in Kenya. I was brought up in Kakamega, Eldoret, later on Nakuru, and then I studied in Nairobi like most young Kenyans. Something that you see very clearly is that there are very serious rural-urban inequalities in education in Kenya. And this is quite amplified in the case of technology and technical education. So while Nairobi here, I'm not sure whether Rongai is in Nairobi, that's a debate for another day.
A motivation.
I like saying that Rongai has Kenyans with the distance of Uganda and the dust of South Sudan. So, an African. Anyway.
And the fire of South Africa.
Anyway, so it was basically Nairobi has the world standard in technical education. That's why Google, Microsoft are here. They're very well trained young Kenyans in software development and engineering. The rural parts of rural Kenya, parts of rural Africa in the general case are 20, 30, 40 years back. And this differential development of societies is normally not healthy. So me and a couple of friends sat and thought about what we could do. We saw that there are basically very young, ambitious people in these rural areas who just don't have the opportunity. Just a road, somewhere, some direction to take, and basically have their way to developing their communities and themselves. So we decided that this is something we could do, get the equipment, get books, I know you were there and you saw, and give these young people that capacity to start spreading this knowledge in their communities. So we are in search, I'm speaking to the camera now, we're in search of young ambitious people from throughout rural Kenya, rural East Africa and rural Africa to try and get these young people who are passionate about technology and science specifically, and to capacitate them to build small science centers in these rural areas which could run for very cheap, and then to have a business model around the science center, maybe have young people visiting, and that could help with sustainability. So this was our pilot project, as you're familiar. The young people are doing amazing. They unpacked those boxes within 2 days, and they were busy with the telescope. I took some time to assemble it. They took hours to assemble it, and they were looking at the moon. It was actually very interesting to see that the aggressiveness, the raw energy. And this is a shout out to Juma. It's just amazing to know that he's already been invited to a conference in Rwanda. He's already getting his international conference at 21. At 21, I was listening to TOK, but that is life. So I'm very proud of what we've done. And thank you. Let me say this in front of cameras. Thank you, Roger. It was amazing.
My pleasure, man.
Yeah, my pleasure.
Yeah, fantastic. So, telescope. Telescope.
Yeah.
Yes. So, we're wondering why this guy takes hours, days, was it, to assemble a telescope. Who wakes up to assemble telescopes? Well, this guy, machine learning is one of the things he has done. It is not the only thing he has done. No, sorry, not by a long shot. Yeah. So, Carringtone, tell us about telescopes and astrophysics.
Roger. Anyway, my background is in astronomy, and this is strange in Kenya. I was interested in astronomy from high school. As we've talked about, I was brought up in urban areas, so we had libraries, and I would read all these astronomy books. I decided to do the course astronomy and astrophysics. It was very interesting. By my first year, I was already being told to program, something that I cared little for. But I decided, fine, you have to do the courses, you have to get the grades. And I did it, and it was interesting in its own way, but I was not too interested. I was interested in mathematical physics and all these other things that I started from. After a while, it seemed to me, I might be wrong, that my interests slowly shifted from mathematics, pure mathematics and all this stuff, theoretical physics, to machine learning and more applicable things. The reason for this shift I don't understand. It could be me jumping on bandwagons. It could be money. No, it's not. But I thought that, given the skill set that I had developed through my undergraduate and postgraduate studies, that it could be easier for me to understand the fundamentals of machine learning, which are just mathematics, right? And they're interesting conceptual problems that we are probably going to talk about: artificial general intelligence, artificial consciousness, whether computers really have intelligence. These are very interesting philosophical conceptual problems that I think have huge ramifications for our societies and for the future, probably for our children or ourselves. So when you see it getting hot, swim towards the warmth, essentially. There's a lot of productive gain from the field of machine learning and artificial intelligence. But yes, it's true, my first love is physics, and I'm hoping to find, in a fantasy world, I would find an intersection of the two. I see. But that is maybe for the future.
Fair enough. Okay, so this has been a three-parter introduction. We have known Carringtone as a machine learning expert. We have known him. He's very humble on camera. We have known him as an expert in machine learning. We have known him as a co-founder of the Kisima Library Project, and we have known him as someone who knows quite a bit about astrophysics and astronomy. Yes. Not to be confused with astrology, which he also knows things about.
Yeah.
Yes. But, yes, now I think we can dive into the meat of the matter. So, Carringtone, what is machine learning?
What is learning? I think we should start there. We had a system called 844 and here in Kenya, and people were critical of 844 that the students never learned anything. These people who are critical, the people who talk about half-baked graduates and etc. What do they mean that people haven't learned in these schools? Learning to me is a process by which, and I'm sure you've heard this ad nauseum, as because I like debating. Learning to me is a process by which you update, let's call this thing an agent, because it doesn't have to be a human being, it can be a cow, it can be a donkey. Rongai is famous for donkeys. So when you point a stick at the donkey just naturally changes direction. Why? Because it has learned to associate that stick with pain, and it knows to reflexively move away from pain. So it has learned a fact about the stick and its body. So that updating your state depending on external factors, stimuli, to me is what is essentially learning. The important thing here is that you have to have some form of agency. You have to have some ability to modify your internals. And this is important because it will have implications for why we think machines are learning.
Fantastic.
Now, let's get to machines. I'm sorry. I had forgotten that entire part. A machine can be defined by 3 steps. Just input, the process on the input, and the output. Input, process, output, IPO. The ability to do this mechanically is what you call a machine. You give a car fuel and then you give it instructions through the steering wheel, and it does something. It responds to your instructions and the fuel. Now, can we get this thing, this mechanical thing, to learn? The answer for a very long time was no, because it was felt that the ability of machines to update the internal state essentially was zero. They had no ability to do this. The last century or the last few decades, it has become clear because of the rise of electronics. This is much more your specialty than mine. The rise of electronics has given us the ability to simulate patterns, and not just patterns, dynamical patterns, so patterns that change with time. And if you can get these patterns to change with time, you can get these patterns to change in a particular direction with time, with a particular desired direction. And this is what you will say machine learning. So getting a mechanical agent to update its internal state with time in a particular desired direction is what we call machine learning. And the ability to learn is called intelligence. So somebody who learns quickly or learns facts faster than the other one is more intelligent than the other, not very complicated. The ability to think fast, etc., is intelligence. So the ability of a machine to learn is an intelligence of the artifice, otherwise called artificial intelligence.
Fantastic. Yeah, so I'm happy that you have gone into artificial intelligence as well, as we discuss artificial intelligence and machine learning. Okay.
Do you like the definitions, by the way?
I do like the definitions, yeah.
Okay.
I have had the pleasure of hearing a bit of them before, and I did like them then as well. So. It's really awesome. Okay, so now we know what machine learning is. So you just said that we can make machines learn. Yeah? It sounds a very big idea. Yeah?
It is.
It is a very big idea. Yeah? So one would ask, how do they learn exactly?
Yeah, that's a good question.
Yeah.
I will start with my usual allegory of patterns. Yeah, we'll go back to these patterns. Information is just a pattern. So Kenya is just a series of dies on this t-shirt. Okay? So information is fundamentally about patterns. Now, if you can get these patterns to change, if you can get these patterns to be represented on a mechanical object, and then you allow them to change with the time, which is essentially numbers. You store numbers in a computer, and then you let them jiggle with time. Anytime they're not jiggling in a way that they're jiggling in a way that you don't like, you punish the computer. Anytime they're jiggling in a way that you like, you reward the computer, and over time it learns to jiggle these numbers the way you want it to, and this is what you will call learning. So it's the important thing here is that you are able to make changes on this state of the computer, just like you're able to make changes in your mind. And the hope is that these changes will be positive, i.e. improvement, and this is what you will call learning.
Fantastic. Okay. Thank you for that definition.
Do we get into a little bit of neural networks or later on?
Yeah, we're coming up to that. Okay, great. So before, as we go in the direction of neural networks and what those are and everything, we hear these terms being thrown around: supervised learning, unsupervised learning, reinforcement learning. What are these?
Good. So you have a child. Do you have a child?
I do not have a child.
We will pray. You have a child, and you need to teach them something. The first step, you want to show them what an apple is in opposition to what an orange is. One way of doing this would be to point at the apple. Daddy, that is an apple. Daddy, that is an orange. And then he points at the apple and says, orange. You say, no, apple. And then, apple. Yes, apple. And then now you have given them some new information. You've taught them. You've caused them to learn. That system of where you are checking the results and providing the labels to these objects is what we call supervised learning. So you continuously check the results during the process of learning and confirm it against what you call ground truth, apple and orange. Reinforcement learning is, am I allowed to curse? I don't think so. I hope not. There's this meme in Twitter circles that says F around and find out. Mess around and find out. This is essentially reinforcement learning. You let the child select an action, a decision, like steal sugar, and then you pinch them. They will learn to associate the stealing of sugar with pain, and hopefully they will learn to avoid that. When they find the lid of sugar open, you've left it open, they will close it and then store it nicely. Then you reward them with a piece of chocolate. They will learn to associate orderliness and what have you with reward. So this way they update their states depending on the stimuli that you have associated with certain actions and decisions. And this is reinforcement learning, i.e. you are reinforcing certain habits and hopefully suppressing others. And supervised learning is where you let the child just roam free, or the machine to roam free, and then it will learn to make certain associations among certain objects. Like it knows that is a tree of apples. Those are different things from the tree of oranges. And this is what we call clustering in machine learning. And this is unsupervised learning.
Fantastic. So for maybe you can give us a couple of examples. What is a use case that is really useful for, say, supervised learning? What is useful for unsupervised learning, and what is useful for reinforcement learning?
Reinforcement learning, So, you have a bunch of tweets. You work at the National Intelligence Service in Kenya, and you're analyzing the security status of tweets and associating them with the regions, let's say. This is not very high security, it's already on the internet, it's data that is public. what you could essentially do is have human beings label those tweets. Positive sentiment towards certain policies of the government, negative etc. And you tell the machine to now learn to make those associations between positive words, which it turns to numbers, and then make those associations between those numbers and the sentiment, which could be negative, positive, or neutral. And then over time, the machine learns to do this. The reason you want to do this is that you don't want to have 1,000 people reading Kenyan's tweets every day. It is impossible work. So you train the machine to do the work for you, and then it can do it relentlessly. So that will be a use case for supervised learning in less security demanding situations. You could use it to recognize objects, for example, traffic, for example. It will learn to recognize cars and movement and patterns. In the case of reinforcement learning, all of you who have apps, games, nowadays the agents who you play against, when you say you're playing against the mobile phone, you're actually playing against an AI most of the time, and the AI you're playing against has been trained using reinforcement learning, sort of to learn to understand chess patterns by rewards and punishments, and then to certain levels of expertise. So when you select your level of expertise here, do you play chess?
I do play chess.
I don't. I don't know why I haven't been able to play chess, but anyway, so that's a good example of reinforcement learning.
And what about unsupervised?
Unsupervised learning. So when you are dealing, for example, with the agriculture, there are people, geospatial analysts. So when they're trying to look at the productivity of the country agriculturally, for example, something that I will really push for in Kenya and East Africa, you will try to understand how much of our land is covered by buildings, how much of our land is covered by productive food, plants, greens, how much is covered by natural plants, forests, etc. A nice place of doing this from the start would be to use unsupervised classification. So it learns to make associations, maybe geographical, for example, that if there is a plant maize in this acre, there's likely to be plant maize here. If there's a forest here, the forest is likely to extend. And it does this very, very well. So a good place to start usually is unsupervised classification. When you have raw data. And then fine tune it as you go.
I see. So it sort of helps you to find out what you need to look out for.
Exactly, essentially. Anomaly detection. So when you have weird things, for example, in a pattern of data, unsupervised models, because they chew on the data continuously, they say this is not like the rest, this is unique, watch out for this. This has implications for health industry, education industry, security industry. Yes, definitely. So you can see that it is not we talked about the conceptual problems, the theoretical problems, probably we'll talk about them, but there are also practical concerns here that may be of interest to policymakers, scientists, engineers.
For sure. Okay. So there's this weird thing that happens with my Spotify. When I open a song, it knows exactly what I want to listen to next, and next for about an hour straight. What kind of machine learning is this?
Netflix, Facebook, Twitter. Their billions come from a simple system called recommender system, and we are now headed to what I try to study. I'm not getting very far with it, but anyway, that's a story for another day. Recommender systems carry out associations between nodes in a network, depending on interests, depending on proximity to other nodes in the network. Now I'm speaking very abstractly, but let me put flesh on this bone. A node in a network is you. You like certain pieces of music. I know you're very adversarial to your brother Douglas, so he probably is the opposite of you, and the devil to your God. So,
Yes.
what it does, it also learns those negative associations. So it says, Roger is the opposite of Douglas. That is a factor when considering what to recommend. So what Douglas likes, Roger is likely not to dislike, something like that. It also does other things. It, for example, does, Roger has been living maybe in proximity. I can see that the account is in proximity with 100 other accounts in Rongai. Well, these people are into Gengeton for some reason. Roger is likely to like cash crops Nyandaru. So it does that and it starts guessing over time. And when you skip a piece of music that you don't like, that is also a data point for it. So it says, he didn't pick that music. Why? It looks at the characteristics and then reformulates itself and continues doing that over and over. It is just pure repeated practicing. Practicing makes perfect.
Okay.
Yeah.
Okay.
Remember, machines don't sleep. So that's an age of us.
Okay. Very good. All right. So we have learned what machine learning is. You have learned a few ways that people go about machine learning, and we have seen some of the applications that we have on machine learning right now. Yeah. So machine learning has models. What is a model?
A model is an imperfect picture of the world. The stuff that is in your head, the stuff that is in my head, the stuff that is in the society, is an imperfect picture of the world. Remember that our entire universe cannot fit inside our little boxes. So we must form mental pictures, mental representations of the world around us. Whatever we form, that thing which we form, that we store it inside our minds, or we store it inside the machine of the mind of a machine, quote unquote. They don't hang me on that. Is called a model. It is a representation of the world. There's a common saying, I've forgotten who said it, that all models are wrong, but some are useful. So models are to be judged by their effectiveness. So if an AI has a model of the world, does it help that AI become effective in the world? Just the same way when you read your notes in high school, you're revising your history notes, you can't capture everything. Does whatever you have captured allow you to get an A or a B or a C or pass?
Okay.
So that is the question. So does your representation of your world allow you to be effective in the world?
Okay.
Yeah. Same for AIs.
Okay.
So a model is an imperfect representation of the world.
Okay. Okay, welcome back. We were just talking about models and what they are in general and in machine learning and artificial intelligence. So, there are different kinds of models. Okay, first of all, you mentioned that models are a representation of reality. Yeah, if I understood you correctly, right?
Yes.
Yeah. So, what does it mean to train a model? To test a model?
Yeah. So, a model is an imperfect representation of external reality. But human beings are not comfortable with imperfection. We are very interested in trying to improve things. So the process by which an artificial intelligence model is improved so that it can have a better representation of reality, it can understand reality better, is the process by which we call training. Just like training a child to have a better model of the house so that he doesn't knock himself all the way through while walking around or stumbling around. So this idea of improving your model so that it can represent reality better, not perfectly, never perfectly, but better, is the process by which we call training.
Okay.
And it's different for different learning schemes, as we talked about. Unsupervised, you just let the model and try and understand the world as best as it can. Supervised, you give it, you tell it that is a wrong answer so that it corrects itself. And for reinforcement, you punish and reward.
Okay.
So even the process by which you train is defined by the earlier three classes of training that we talked about, of AI that we talked about.
Okay. Okay. So the next question is a bit longer. because the first part of it is to do with the model itself. Yeah. So far from what we've gathered is that when we need to build a more accurate machine learning algorithm, machine learning model, as you mentioned, we need to train it. Yeah. So I would guess that the more things you have to train it on, the better you expect it to be.
Yes.
Okay, great. So, what component of this equation is inherent in the model itself? Because because I understand that there are very different kinds of model architectures, and I also understand that there's a study I came about. I think we will put the link in the description that discusses different types of models, which are both trained on a lot of data, and the accuracy was, at the end of the day, was not very different for the different model architectures. So the question is, given enough data, is there something inherent in the model architecture that limits what you can do with a certain model as opposed to the next one?
Good question, Roger. There is a theoretical understanding within computer science that essentially, if you have an unstructured neural network, maybe we need to talk a little bit about neural networks.
Okay.
Neural networks are basically implementations of artificial intelligence that rely on networks of matrices. A matrix is just an array of numbers which receives, again, the input, the processing multiplies, and then gives an output, otherwise called a function in mathematics. So these arrays of numbers learn to get adjacent or closer, or to pass the numbers, the signals, to other arrays on the basis of the labels that you have given them, or on the basis of the actions that you want them to take. And over time, this network learns to know where to pass the signal and where not to pass the signal, whether to accept a signal or whether not to accept the signal. And if you do your wiring correctly, you end up with a model of your data that is very good, in that it is a better representation of your data, and your data is reality, quote unquote. I would analogize it with cities. So cities are very dynamical objects. We don't see them as such because we live in cities for roughly 10-20 years. But you can see even the change within Nairobi, within Nakuru, within Kisumu, within Kakamega, cities and towns. They learn to specialize, if I may say so. So Nairobi has become the jack of all trades that has everything. And then Kakamega, Mumias was a town of sugar and all these things. And you can see that the structure of the city itself, all roads lead to Mumias Sugar when Mumias Sugar was very active. In Nairobi, all roads lead to government because people will come to Nairobi primarily for government services or something like that. But the city is dynamic. So right now Nairobi is known for River Road and downtown more than the government services, because government services have been decentralized, and therefore there are more people in downtown. So this very elastic way of adjusting yourself, adjusting the agent depending on depending on external stimuli, is the interesting thing for neural networks. The idea that networks are able to adjust themselves, just like you drop friends and pick friends. You do. You're not amazing. You're normal. So exactly, you are adjusting your social network to your specific circumstances. Please drop it again. So that is exactly why neural networks are very attractive. The ability to adjust to themselves. Now let's get to architectures. It has been understood that although, yes, you could train a network, because a network is infinitely adjustable. You can fix it, you can remove this and put it here, and then move this and put it here, and see if the thing works. Although it a network, just a random network could learn anything, it has come to be understood because of engineering, because of reality, that it is more efficient to arrange these nodes in the network much better so that they can deal with specific data sets. So for example, although this has come to change recently, there was this architecture called convolution neural networks, which was seen to be very efficient with images because they would learn to relate a single pixel in an image to its neighbor pixels, and that will learn to segment or classify objects in an image very well. And this is why Google is nearly perfect with cats and dogs and all this other stuff. The other architectures, recurrent neural networks, specifically are designed to process sequences. So sequence could be anything, words for example. It could be stock data, share information, share price information. So anything that is sequential weather data, it could learn to adjust and predict itself because it does something like check itself before. And since a sequence depends on its before step, it can learn a sequence like that. It can learn a sequence on the basis of previous steps. So you can rearrange your network in such a sense as to make it able to understand a specific data set. And this is part of AI engineering.
Fantastic.
Yeah.
Okay, great. Thank you for the explanation. So we have talked a bit about architecture. We have talked a bit about neural networks. Yeah. So before we actually zero in on neural networks, there are other architectures of models that are not necessarily neural networks. Yeah. So could you talk a bit about some of these things? Just one or two, and just to give an idea of what's out there that's not outside of the world of neural networks.
There's this very interesting thing in evolution where they show the monkey and then the thing gets more straight and then has a stick. That linear evolution. Of course, we all know that it is not true. What happens is that life does something much more interesting. It tries all possible ways, like a tree and the branches, and then some fail and then some work, and then somehow you end up with Homo sapiens somewhere as a productive species. So it's a similar process with AI evolution. What happens is that there were multiple groups trying different things, and different methods were effective for different problems or seemed effective for different problems. So one was called regression. This is taught in high school actually, in different words. So you have a graph. I'm sorry to anyone who hates mathematics, I apologize, but the teacher has to do his job. So you have a graph and you have data points there. Scattered somewhere like that. And then you teach yourself, or you're taught by the mathematics teacher, to draw a straight possible line that goes through all these data points in some reasonable way. The drawing of that line that goes through these small dots is what you call regression. Finding the rule, which is your line, that best fits the data, the reality. So this, you can teach a computer to do this by varying these numbers, because dots are just numbers to a computer. It can vary these numbers and try to find the general rule that varies these numbers as perfectly as possible. Again, never perfect because of reality. So that's one. There was another one called support vector machines. Support vector. I'm passionate about it. They are my for the people in the camera. They're my first machine learning models. So first crash. So
we need to talk a little more about that.
My first crash.
Yes, and how
we're not going to talk about my first crash.
In the future.
Support vector machines use the coordinates of these dots. So remember that a coordinate is just a number that describes where something is. So for example, Roger, you're 3 steps or 1 step next to me, but 3 steps behind this wall or next to this wall. Yeah, I can use that step of 3 and 1 to describe your position in this room, right?
Okay. Yeah.
So if you have these numbers of these dots, you can essentially tell the machine to try draw a line that best fits these numbers on these dots, and these numbers are called support vectors. So this general, there are very many. I know you like random forests, k-means. There are very many sort of different approaches to machine learning. They are called classical approaches because they generally were dominant before this neural network elastic dynamic picture took over and ran AI basically.
Fantastic. Okay, so actually that was the basis of the next question.
Yeah.
Neural networks, are they everything or almost everything in AI at the moment?
Yes, they're almost everything. Because this ability, the theoretical reason that we discussed, that they can adjust themselves to any problem, gives them such powerful generality that if you almost throw any problem at them, given the right conditions and given the right amount of computational power, because you're using computers, they're able to solve it. So this versatility has given them extreme power to handle almost any problem, and they are able also to scale. Some of these methods that we've talked about do not scale. By scale, I just mean handle a lot of data because of the computational complexity. Some of these algorithms do not handle large amounts of data, but we are in the big data era, as probably some of the listeners know. So we have to think about methods that will scale with the amount of data. So for this reason, people find neural networks attractive. Plus, they're conceptually attractive.
Yes. So okay. So let's talk a bit more, just a little bit more about neural networks. What are they called neural?
Good question. Good question. There were computer scientists in the 80s, I forget their names, I have bad memory, who basically wanted to approximate the human brain. Now, the human brain learns exactly this way. So, there's a human brain somewhere speaking very fluent Luganda and almost no Kiswahili. Very fluent Chichewa, almost no Kiswahili. Very fluent Isizulu, almost no Chichewa, something like that. Why? But we are the same thing. We know we are the same thing inside here between these skulls. Inside the skull. The reason is exactly the same. The reason is exactly why Nairobi does not look like Johannesburg. Neural networks are able to, any network actually, is able to adjust to its conditions. Now, these people wanted to approximate this kind of very versatile behavior because they thought that it would be the easiest way to lead to artificial intelligence. In fact, they were ignored. There are a group of Canadian researchers or Canadian-based researchers. They were mostly ignored because their work looked like it was fringe science or something like that. But eventually, their methods did bear out when the data came and the computational power came. Neural networks proved themselves to be very versatile, and that's why people find them attractive. They're called neural networks because just they're meant to approximate the brain. And of course they do it poorly, but they're still very effective.
And we're still pretty early on, right?
We're still 10, 20 years. So what would an artificial neural network look like in 200 years? I'm sure maybe we'll speculate after.
Fair enough. Okay, so now we know a bit about what AI is. We know about neural networks' place in AI. Now there's this thing that has taken us by storm. It's called ChatGPT. What is ChatGPT?
Good. Remember we talked about 2 things. We talked about natural language processing and we talked about models. Natural language processing is the process by which you try approximate language patterns in numbers so that machines can represent them. Okay? And the process by which you do this work, you're essentially trying to model language. I have a particularly good model of Shen, an effective model of Kiswahili, maybe effective model of English in my head, and no effective model of, I don't know, Greek. Yeah. So what these computers do is try to form a picture of this language, otherwise called by definition a language model. Now, this process of language modeling was very ineffective. I'm sure you interacted with Zuri or other earlier chatbots. They are pretty mechanical. You can do one of three things, and then by step 3 they are already calling for help. Serikali's idea. After they were seen to be not particularly effective, the language models, the small language models, they were not particularly effective because they did not have a good enough model of the language. So the researchers at OpenAI in San Francisco decided, what if we scale this properly? Essentially take everything that has ever been written in English, but do a good data curation, purify the data, process the data, make it as good as possible, and then pass it to the largest possible machine model, and train that largest possible machine on this largest possible data set. What will happen? Theoretically, there were some people who were saying that there will be marginal improvements. It will still be the same silly chatbots you've interacted with. But what happened, and this is why networks are very important, that's why Nairobi is not 1,000 Nyeris, Nairobi is 10 billion Nyeris. You know, I like using this example. What happened is that an understanding of the language, and not only the language, the conceptual basis of these words. So not only the syntax, but the semantics, the meanings of the words emerged in this large language model. And then they continued training it using a process called reinforcement learning by human feedback. So essentially rewarding when it says something intelligent and punishing it when it doesn't, or helpful. They did this repeatedly for a number of times, and somehow something very interesting emerged that almost looks human, or is at least able to use language the way a human being could, and definitely better than me. So that is what happened. It's just a matter of scale. And that's something interesting about networks. We've said that Nairobi is not 1,000 Nyeris. The reason we are saying this is that I hear that in Nyeri they put soup in pizza, and they don't have a theater. So when you scale up populations, you don't end up with 1,000 times a single person. A university is not 1,000 students. It's something interesting that emerges from the interaction of 1,000 students. Something more than that. I'm sure you've these things I'm obsessed with. I'm sure you've heard of the sum is greater than the parts. A system is the whole is greater than the sum of its parts. This is exactly where that idea comes from. If I take a handlebar and a tire and a spoke and put them together, that is not a bicycle. But if I arrange them specifically, it becomes a bicycle. And while these parts themselves cannot take you to town, the system, the bicycle, can take you to town. So that is essentially what happened last year.
I see. So what you're saying is that we have a model, because it's just because of the network, the size of the network, it is able to do things that the smaller models could never even imagine.
Yes.
Okay, interesting. So let's talk about that for a second. What we're saying is that a machine learning model, and a large language model like ChatGPT, is able not just to know what I'm saying, but it can tell what I mean.
Yes, it can try and tell what you mean.
Yes, and from what I've seen, it's actually pretty good at that, right?
Yes, exactly.
Okay.
Yes, and that comes from that, the idea that language is much more than syntax, i.e. the patterns of the words. It's also about the information behind the syntax, the meaning. And this was a computationally hard problem, which, to my opinion, and I'm not an expert in the field, was solved for most intents and purposes last year.
I see. Okay. So, is it possible that this model knows things about language that we don't know yet?
Yes, it is possible. It is possible that it can, with sufficient, prodding or prompting. It can do some things with the language, especially the English language, that we would find enriching. And I'm sure there are some people in Twitter who have done this. Yeah, it could, for example, crack a joke that could make you laugh roughly.
Right, yes,
so and laughing is an element of surprise. Yeah, element of ascribing wittiness to the thing that is giving you the joke. So this is it already doing something interesting with the language that we would have seen. Yeah.
So okay, great. So I think at this point we're just going to dip our toes into a sort of philosophical question. Yeah?
Yes.
Is it possible that these large language models know more about how we communicate than we do ourselves?
In some aspects, yes. I will say yes. And this is why. The claim of big data analysis, big data science, is very simple. The claim of big data science is that there are patterns which can emerge from big data. I like saying data rather than data, so allow me to say data. Like a Bantu. The claim of big data analysis is that patterns can emerge from larger data sets that cannot be possibly seen in smaller data sets. And this claim has been proven time and time again by Facebook, Twitter, you were talking about Spotify. Yes, patterns that you cannot even think about. Maybe your music recommendation came from a Bulgarian somewhere who is more soulfully, quote unquote, connected to you than your neighbor, your physical neighbor. So these non-trivial patterns can be picked up by large data sets. This is the claim of big data. If that claim is true, and I think we have sufficient evidence to say that it is true to some extent, then yes, an agent, a being which can read and process everything that human beings have ever written for the last few hundred years or 1,000 years could possibly understand language, at least, if not the universe, definitely not the universe, but at least the concepts of language that we don't understand. Yes.
Okay.
Yes. Which makes it a very good editor.
Yeah. Because editing is primarily out of experience.
How do you model language exactly? An editor has a better model of language than you. That's why an editor is important.
Wonderful. We're going to be talking about jobs very soon, so we'll keep that. Okay, great. So now we've seen that ChatGPT is impressive. Yeah, GPT-4 is orders of magnitude better than GPT-3. Is that accurate?
I agree completely. Yes, yes, it is.
Okay. So, but there seems to be one challenge, we would say, with the GPTs, with the ChatGPTs, which is that they're primarily text-based. So, do you know about any plans of adding more kinds of media into these models?
First, I will say that the company that you talked about that we are forming is essentially, hopefully, could do something here.
Okay.
I'm not sure whether we will be able to do anything useful here, but the idea is simple. The theory is very simple. Computers don't also understand pictures. They understand numbers. And these pictures register as intensities of light, certain pieces of light, red, green, and blue, in the computer's memory. So those are numbers also. In the case of sound, intensity of numbers, intensity of volume is a number. So the hope is that, and probably people are working on this right now, they'll probably pass us by. A computer, a machine learning, an artificial neural network, specifically these things we haven't talked about called transformers, could learn to make multiple associations between different modes of data. So for example, it could learn to understand sound and how that sound relates to video and how that video relates to text. And using these multiple modes of data, it could then have multimodal capacity. So many modes, multi-modes. Yes. So there's research. This is an active area of research and development, and probably the company which cracks this first, I might be speculating here, could get to $1 trillion valuation. Because think about it. You have a personal assistant who you get on your phone, right? And you say, "Hi Sarah, I want to email so and so telling her so and so," and then she drafts the email, because the agent is aware of all your previous emails and all your interactions with Sarah. So further to my last email, we talked about this and this, and then we did this and this and this and this, and then after Sarah responds, after your receiver response, not Sarah. Sarah then tells you, "Oh, she said this and this and this," and then you say, "Oh, fine." Human beings would rather interact with a visual agent than a text-based agent. Sometimes I see ChatGPT writing walls of text, and then I just close the laptop and sleep.
Too much.
So I'd rather talk to a person or something like that. And there's a business case for this, definitely. Everyone having a personal assistant, that is a strong business case. So can you solve it?
Yeah, I will give it a shot for sure.
I like the arrogance.
Yeah, okay. So, on Google I.O., I think it was 2 or 3 years ago, they announced Lambda 2. So Lambda 2 was, the way they did it in the demo is that his name was, what's the name of the CEO? Sundar Pichai. Yeah. Sundar Pichai told the AI that he wants to forward a YouTube video to the part where there's a lion roaring. So it was able to process the visuals of the video and the sound and all, and to bring that, take you to that place. So on the other side, we have Elon Musk creating humanoid robots. And saying that his projection is that very soon the humanoid robots are going to be taking over. They'll be accounting for a larger market share of Tesla than the cars. Yeah, that's what he said. So it sounds to me like what you're saying about it's personal assistants.
Right next on,
It is, huh?
It is right next on the door.
Interesting. Interesting. Welcome back to our discussion about artificial intelligence and machine learning. So just before the break, we're talking about ChatGPT and multimodal approaches to what ChatGPT is doing and what that would look like. So now, at this point, there is a trajectory that we're going at. We started with simpler, the classical kinds of models. We went into neural networks. Now we're talking about large language models and what they're able to do. And what we find so far is that we have a model that can do a lot of things, which is different from what we had before, which were models that were specialized on only one thing, only one task or one group of tasks. Now we have something that can do more. So, what is the next step?
What is the next step? The $1 billion question or $1 trillion question, because our world economy is expanding rapidly. Let's take a step back to these classical models and the rudimentary models we were talking about. Now, when AI is created, and most of the AIs that we've interacted with, it is created to do one specific task. You're teaching an AI to play chess and nothing else. You're teaching an AI to write and nothing else, to compose basic messages. You're teaching it to recognize cats and dogs and nothing else. These particular AIs are called narrow intelligences, meaning that they are particularly programmed to do a specific narrow task. For sorry. Tutakat tu alafu nitarudia. It's okay. Let's fix it. Iko sawa? Iko sawa? Iko sawa? So that They are trained to carry out specific tasks, very narrow tasks. These are called narrow intelligences. Now, you want to program something that can do multiple things for you. Write an email for you, compose a song, wash your dishes if possible, organize your day, plan your day. So it has to understand the logistics. These specific agents are called artificial general intelligences. So very simple, because they can do multiple tasks. A human being is an example of a general intelligence. Cows are example of general intelligences. So for example, you are right now reading while asking me questions, while talking to me, while taking perception of your room, of the room that we are in. All these things your mind is able to process. It's also able to process the posture so that you are stable. It is doing all these things just like that, spontaneously. We would like, or there is a business case, there's also a conceptually interesting case for the development of such intelligences. These are called artificial general intelligences. Now, when you scale that up, you want it to be very, very powerful, essentially, like the large language model in relation with the normal language models, smaller language models. When you scale that up, there's the hope or the guess or the postulation that they will become super intelligent. So an computer algorithm that can theoretically solve any problem that is feasible. That is called an artificial super intelligence. So the next immediate step for me, and this to me, in my ill-considered opinion, is in the next 20 to 30 years, is the beginning of the rise of artificial general intelligent agents. So these agents that will be helping you carry out multiple tasks. GPT-4, in my opinion, is a rudimentary form of an artificial general intelligence. This is my opinion, not the opinion of computer scientists. So please find out from them. The reason I say this is that it has been demonstrated. GPT-4 can play a rudimentary game of chess. It also programs well. It writes code well, apart from speaking English. GPT-4 speaks fluent Swahili, better than I do. So, and if you're sticking to that definition of the ability to carry out multiple tasks, then this is a general intelligence, although text-based general intelligence. So the question is, can we make them multimodal? Can we make them agentic for them to be able to do actual things with the physical world, for example? These are questions for another day, or maybe another minute, I don't know. But that is the basis of artificial general intelligence, an AI that can achieve general classes of tasks. Yeah, there are some people who add on the rider that they should be able to carry out these tasks generally, as well or better than a human being. But I don't add that rider because now it gets into, is it really, is it not? And I'm not a big fan of thresholds. I'm a big fan of spectra.
I understand. I understand. Okay, that's interesting. So, you would say that right where we are right now, we are at the point where we have created artificial general intelligence in the real sense.
In the real sense.
If we let go of our biases, of our human biases about how we love our race and all, and we stick to what
species.
Yeah. And we stick specifically to what the definitions are that we agreed on beforehand, before things started getting a little complicated. Then you would say that we have AGI already.
Yes. That is my position.
Okay.
What I would push, and my friend Martin and I like talking about this a lot. We would push for scales. Just like you don't have thresholds of consciousness, you don't have thresholds of intelligence in the biological world. You do recognize that there's a form of swarm intelligence in ants, that they're able to do intelligent things. There's a form of intelligence in cows. There's a form of high intelligence in elephants. For God's sake, they bury their dead. They mourn their dead. and consciousness too. I will also push for such a scheme with AI, rather than thinking of artificial general intelligence as a mile or a stop. A certain sign stop will come as we are going along, and we will say we have reached AGI, and then everything past this is AGI. I would prefer scales. So calling GPT-4, for example, a scale 1 general intelligence. Very low general intelligence, but general intelligence nonetheless. And then you could get to a scale 10. Maybe that would be an artificial super intelligence. And this will help us think. There's a practical reason for this. It will help us think about policy and social governance of these technological systems. So once it is understood that we are in the dawn of artificial general intelligence, the hope is that human beings will start to think differently about the technologies they are handling. These are no longer toys. These are no longer interesting things that classify cats and dogs. We are dealing with very, very powerful systems, and therefore the policy should match the power of the systems. And this is why scale thinking is useful. Just the same way, thinking about elephants as conscious beings reduces your callousness towards them. There was a time we thought that elephants are basically ivory tusk producers, but we've sophisticated our thinking because our understanding of the nature of elephants and elephant societies is more sophisticated.
I see.
This is the hope for machines too.
Okay, thanks for that. Right, now, at this point, we have found that GPT-4 can do a lot of things better. You said it speaks better Swahili than you do.
Yes, definitely.
I suspect you speak
because I was
better
brought up in
Mumias.
Kakamega.
In the wild west. Yeah. So, I suspect you speak better in Kiswahili than I do. So
that's a problem.
Fair enough. Yeah. So we found that it can do a lot of things better. Yeah. If you have tried to write some lines of code, then you will be impressed at the skill of GPT-4 in coding.
Yes.
I know I am.
Yes.
Yeah? Because I've tried to type things in plain English, and it has generated very complicated things that I had to work to just understand what it has done.
You had to work through.
Yeah. So that was quite brilliant. Yeah. So this brings us to the next question, which is the questions of our jobs. Yeah. Now, if I am a programmer, that is my job. This thing is a programmer. Yeah. And at my own admission, it appears to be better than me if it understands what I'm trying to do. Yeah. Now, the problem is it's not just a programmer. It can do the same thing for writing text, creating graphics, even in some cases.
Yes.
Yeah. It seems to be applicable in a lot of areas. Yeah. So, how do I expect to have work tomorrow?
Yeah, that's a very good question. There are two modes of thinking about this. And this is where I differ to Yuval Noah Harari. He's a historian, he's a famous historian. There has been this continuous argument that the AI revolution will be similar to the Industrial Revolution. So before the Industrial Revolution, we had horse carriage drivers, and they would ride the horses and the carriages and everything. And then cars were invented, and there was a transition time where people were really worried about where all these horse carriage drivers would get their work. It so happened that the invention and deployment of cars, transport vehicles, so rapidly expanded the economies, especially of Western Europe and the United States, that it absorbed all these people in some way or another in the economy. They all found something to do. Yes. That's mode one. That revolutions, by their nature, transform the nature of work. And transforming the nature of work is yes, destroying work. We have very few horse carriage riders. I only know one employed by the Queen for ceremonies, the Queen of England. Or, not only does it destroy, it creates. So this action of creation and destruction in the economy is what is useful for a dynamic economy and a dynamic society. So that's one mode of thinking, particularly taken by libertarians. So they want this technology tomorrow. There's a second mode of thinking about this, and I defer to Yuval because he is particularly poetic about this. He says that it could be possible that we are not the horse carriage riders in this story with the AI revolution. We are the horses. So, in the case of horses, the story is different from them. They had such a central role in the economy of the world that mobility basically depended on them. And they were displaced so quickly, so ruthlessly, so permanently that they are a curiosity right now.
Yes.
When is the last time you saw a horse? When is the last time you saw a car? It was a minute ago. It could be possible that when we replace our cognitive abilities by the cognitive abilities of machines, that we become a curiosity effectively to the world economy and to the society that we've created. That there will be an irreplaceable, useless class, as Yuval calls them. And this could be 90 to 95% of the human population. At economies scales 10 times larger than now. So it will be a huge paradox that we have an incredibly productive economy with people who are not in employment. What would that society look like? What will be the effect of having a permanently idle class of people, even if they are materially comfortable? We don't know. So, I don't have anything clever to say here rather than regurgitate these 2 points and let the viewers decide in the comments which path we are going to take.
Okay, fair enough. Okay, so
I'm sorry for the depressing uncertainty, but
no.
I happen not to be a prophet.
I see.
Yeah.
So my inkling is that it is not entirely uncertainty. I feel like you might have a
leaning.
Yes.
Where do you think I lean?
I think you lean in the second scenario.
Yes. I think that long term our economy is going to be taken over in the very, very long term because of the situation, the development of physical robotics with the sophisticated world models that these AIs are building. When you combine these 2 things together, I find it very hard to believe that we can still run the economy on the basis of human hands. This is going to be differentiated and varied across continents and regions. And Nairobi will probably see the effects of AI, this negative or positive. We don't know whether there will be positive effects of AI earlier than, I don't know, some village in Kenya. But there is a permanence to it. Yeah, it is not hype. This is what I believe. Yeah, it's not hype. So I lean a bit on the side of danger. Danger is coming, and we need to reorient our social systems probably so that we deal with these new technologies. But I might be wrong. Yeah. Maybe it could be I'm naturally cynical. Am I naturally cynical? You've known me for a long time. Okay, then it means there's a problem. Somebody is nodding at the back. He thinks I can't see him, but it's okay.
Producer.
Exactly.
Fair enough. Okay, so
I want him replaced.
fair enough. Yeah. We don't take a poll on that for Okay. So, I reluctantly agree on the long-term future. That we are going to be, we might be replaced in a lot of the things we do, and that it might be a reality, a very sour reality that we might have to face. I also think there's a kind of meager optimism that we might not be around to see the worst of it. It is not the best kind of optimism because it has implications on the generations that come after us. But It is there, yeah. And every day that passes, that optimism dwindles a bit because the rate of innovation in AI is
It's crazy.
Yes. So do you think this thing can happen in our lifetime?
Now to speculation. And everything I say here should not be held against me.
Okay.
If we are able to solve what Elon Musk thinks that we will be able to solve, and there are good theoretical reasons to believe that we will solve it, the problem of being able to represent a human mind inside a computer, because again, it's networks and it's information. If we are able to carry these networks and information into the minds of human beings, into the minds of computers, into the innards of computers, essentially do mind uploading, yes, then the human species, and to me this is worse than losing job, losing employment opportunities. The human species itself does not have long-term viability.
I see.
Now this is extremely scary, but we come from a continent that has destroyed so many species so that the human species is born. We talk about them. Remember I told you that it is not a line, that the Egyptopithecus gave birth to Australopithecus and Australopithecus gave birth to this and this. That's not what happened. These were groups of beings in the continent and in Europe that were competing for resources, and the more ruthless beings, the Homo sapiens, killed off or either overpowered all these other groups of human beings over time and came to dominate the continent and eventually the planet. So these beings, because of the existence of the Homo sapiens, which are hominids 2.0 or something like that, had no long-term viability. Could it be possible that we will have mechanical descendants who are much more powerful than us, who cause us not to have long-term viability as a species, just because of their agility, the intelligence, the ability to reproduce effortlessly? Remember, the reproduction in human beings is not effortless. So could it be that we don't have long-term viability? I don't know. But I see a possibility in the long-term deep future of our species that it could be the case.
Okay.
And I remember I wrote a blog post trying to process the last day of the last human being on Earth.
I remember.
It was particularly difficult. That is what I was trying to understand. Do we have long-term viability? What do you think?
Before I tell you what I think, Carringtone has a blog post, a blog. The blog is called Wazo La Wiki, Thought of the Week. Yes. So here he discusses a lot of these things that we have to talk about here in artificial intelligence. He also discusses a bit of astronomy.
Physics.
So feel free, we will put a link in the description. You'll be able to have a look at what the thoughts that go on in this mind that we have seen today. And
Disturbed mind.
So great.
Thank you.
Okay. So my thoughts on the grand future of the species are at this point they're a little bleak. I am very sorry to say this. But I think that we are building something that is better than us in a lot of ways, or it has the ability to be better than us in a future that seems ever nearer. So there is a risk there that if you just follow the path, then it is almost, assuming any rate of improvement, then we're getting to a place where where it is going to surpass what we find ourselves special about. So I think that is a concern for me. But what I believe is that the human experience, we have a bond. A human bond. We like things that are made by other humans. It appears to be innate, even. So I think our entire economy as a species, our entire existence will transition from the pragmatic to the more nuanced to the more creative, to the more experiential bit, which is to me it sounds like a great experience. I hope we're not too hung up on solitude. We have a graph that is going towards solitude as a species. I think the more we go away, the more we live in silos, the more we live alone for a long time. So if we can conquer that, then I think we have a very promising future in a world where we have mechanical machines that do most of the hard work for us, and we get to enjoy life.
Yes.
So that is my optimism.
I am in complete agreement with you. And actually, we were to talk a bit about African technology. I was to talk to you a bit about African AI. But anyway, this is something that I think Africa has to offer the world. Something very unique. In my little travels, I have realized that there is a much stronger sense of community in Africa. It could be because of the product of environmental or economic factors, when you live in a society where everything is in an app, everything can be delivered to you, then your need to have a strong social network maybe shrinks a bit, not too much. People still enjoy the company of family in Europe, but I think in Africa that sense of community is much stronger, possibly because our survival depends on it, possibly because of culture, and possibly because of a combination of all these factors. I think that if we start advocating, and this is what I was trying to push for, community-based technology. So the idea that technology as a tool of community, not as a tool of the individual, as a tool to solve communities' problems, not as a tool to create billions for the individual. If we advocate a different style of technology, then maybe Africa has something to offer, something very unique, something very interesting to offer the world. And I agree with you completely. There's this movie I watched called Her, where somebody's job is to just go to the company and write heartfelt messages and pass them forward to the recipient. So you're hired to write heartfelt messages. It could be possible that such weird forms of artistic creations are created, and we could head towards that direction. It is true. I find there are particularly interesting art forms I find prompted by AI, but it does not replace this for me. It does not replace something created by a human being for me. Maybe it's something emotional, something, I don't know. But there could be an artistic explosion in the short run.
Okay.
That would be lovely.
Fantastic.
That would be lovely.
Welcome back to the final segment, where we've just been talking about jobs and what that looks like for us in the long term. But we're going to switch it up a little bit and talk about what is in our more immediate future, what jobs are going to look like in the face of artificial intelligence. We're going to be talking about how we can use AI to make us more productive in our jobs, and how we can leverage it to go ahead and do things in a faster way, in a more efficient way, in a better way. So, Carringtone, right now, there seems to be things that artificial intelligence can help us with day to day. One example is if you have to generate sample information, that would take you a long time if you're doing it in a more traditional way. If you're doing it by hand, it will take you a long time. It is easier when you're using programming, but with things like ChatGPT, you can just say, generate for me 1,000 things that look like this, and it can do that for you. Another part is in more routinized things. So, for example, for our AIs that remove the static from audio, so that you can get a clean audio. There are AIs that remove backgrounds from images, so that you can get an image with no background and such things. So it seems clear that we can use AI as an aid, so that instead of having it as an adversary for competing for the same jobs we can actually use it to do our jobs better.
That's true.
So the question here is, Do you agree, first of all?
Yeah. So, the reason I got into this industry is that I'm fundamentally optimistic, at least in the short term. And by short term, by there, I'm talking about 200, 300 years.
Okay.
So not 5 years. I mean, I'm optimistic in the short term about the effect of AI. For example, we should think of it as something like electricity, something that is going to fundamentally underwrite our entire existence. So that when Kenya goes off for 24 hours, it's a serious issue, it's a national security issue, it's a health issue, it's a logistics issue, for example. Throwing shade at the government, of course. But can you start, if you start thinking of artificial intelligence along those dimensions, you start asking yourself, what is it that I can do without electricity? Ask yourself the polar opposite of the question. What is it that I can do in my work with AI? That is a very serious question. It's a money maker of a question if you're particularly creative about it. So for example, we were in Maraland and we were talking to hairdressers, you remember? And we asked them, you could prompt AI to draw African braids for you in a particularly creative manner and start to sell this as products in your own firm. So that is something in the community that can immediately change the outlook for that person, because they will go and braid somebody and the pattern will be so unique and so creative that somebody else would ask to be done for, and that will create essentially a market, because our African ladies and even our men like to be artistic about their hair. So that's something that is immediately applicable. And down there at the community, we are not talking about national security issue, healthcare issues. Law, for example, lawyers, as I was told, have a difficulty processing all this information, jurisprudence. So what if you could feed that to a large language model? And I'm sorry, I'm selling our business case here, but whoever can work on it, please go ahead. And then you will have a personal assistant there. What if you could have a personal assistant in education, for example? A teacher is teaching 60 students, each of them have a laptop or a tablet, and the tablet is giving each student specific attention. The AI model is giving each student specific attention and could maybe notify the teacher if a particular student needs a particular form of attention. Interactive education systems. I do not see in the short term, because of our evolution, I do not see us being taught by robots. This is not a picture that is in my mind, because we like stories told by other human beings. Physically, in fact, Zoom proved this for us. Handling a class by Zoom is just a headache. So we are clear that technology is going to be integrated into education systems. It's not going to overturn education systems as it has done for the last thousands of years. Even books were integrated into education systems. People do not say there's no need for a teacher because there are books. For the same reason, we will not say there's no need for a teacher because there's AI. So there's a business case, there's a social case, there's a political case for starting to think about how to integrate all this information, all these systems into your daily work. And this is going to create value whatever place you are working. I've just given the example of the hairdresser.
Fantastic. Fantastic. Okay, that's interesting. So it means we can apply it in just about any job, yeah?
Yes.
If we just take the time to see how.
Think. Yeah. Critically, creatively, yes.
Okay, that's encouraging. It's quite interesting.
Yeah.
Okay, great. So on to our second last question. So when computers came around, they were very expensive. They got cheaper with time. When the internet came around, it was harder to get the domains and to get all of those things. It gets easier with time until now. Yeah. With artificial intelligence, it seems to be a little different, because it seems that to create a very good model, first of all, you require a lot of money to buy the computing power and to process that amount of information. Yeah. So it appears that what might be the case is that we will have very few companies that control, and by very I mean extremely very few, maybe 2, 3, that control all of the world's artificial intelligence, or at least have orders of magnitude better artificial intelligence than everybody else. Yeah, and we will have to build on top of them. Yeah. Do you think that's a problem, especially as an African? Do you think that's a problem?
Good, wonderful question. Yes, I think it's a problem. Let me start from there. Anytime you have resources in a network controlled by a single node, that network is unstable. There are good reasons to think that the network is unstable. Weaknesses in the network, in the node, become weaknesses of the network. So even in the abstract, it is a bad thing. For Africa, it means that, like, for the last 200 years, our technological fate, which ends up determining our economic fate, which ends up determining our social and political fate, will again be decided in Europe and the United States. This to me is an unacceptable state of affairs, and there needs to be two remedies. One is something I call AGI, Africa GPU Initiative. We sometimes get confused in thinking that these systems do not need physical infrastructure. There must be physical infrastructure underwriting these systems. It's only that they're in San Francisco, California, they're in Dubai, or they're in China. Let us build our own physical infrastructure. It has to start from there. And then on top of this, build the capacity of individuals like you, like Juma, who can exploit this physical infrastructure to create Africa's models. I read of this very interesting article a while back in The Continent. It's a continental newspaper, that their gods are not our gods. If you ask the American companies why they are building these AGIs, they have totally different stories coming from totally different value systems for why they are doing these things. We would probably want to do different things. We would want to, instead of immortalizing ourselves, like Elon Musk, we would want to immortalize our communities, our culture, our practices, our language, and this is where we start. So that's one remedy that I would push for in the short term. In the long term, we should start becoming clever. There's a certain sense in which societies can leapfrog the technological development of other societies. For me to settle a complete financial transaction in Europe, I need a few hours for it to reflect completely in my account and in your account, for the balances to completely balance. To do that with M-Pesa, I take seconds. My money is deducted, it is recorded that it is added to your account. And all this is done almost instantaneously. So that's why people are arguing that Kenya is one of the financial technology centers of the world, not of Africa. Can we do similar things with the AI? Can we start thinking about intelligence as compression? Can we build smaller and smaller models that can fit in smartphones, in laptops, AGIs that fit in small laptops and mobile phones? Can we give this power to the community so that the values of the community are reflected in the values of the systems they use? I genuinely am skeptical of Silicon Valley prescribed technology. I would really push, and this makes me a nationalist or whatever, but I would genuinely push for different versions of technology. There's a reason for this. Once we have diverse stories, Chimamanda Ngozi Adichie, the danger of a single story. Once we have diverse stories that come from diverse countries with diverse values, then the best can emerge. Once you only have Silicon Valley selling its values through Hollywood and the products, then Silicon Valley's values becomes the world values. And do we want this? Do we want the full stop at the end of history, or do we want the sentence to continue with Africa's young? That is a question for Africans to decide.
For sure.
Yeah.
For sure. Thank you. That is very insightful.
I apologize for my rant. Yeah.
Fantastic. Okay. So I hate to finish this conversation because I'm really enjoying it.
Yeah.
But unfortunately, we have to end this conversation at some point. Yeah. So I would like to, at this point to just ask you. Okay, before we finish it completely. Supposing we have people in the audience who would like to get started in artificial intelligence, how would you recommend that they go about it?
Yeah. There's this amazing university that I would ask them to join called YouTube University. The point, I will just give 2 tips. One is start somewhere, and I would recommend YouTube. First, there are all these videos for learning how to install these things on your machine or how to run them in a cloud. So first learn how to do that, to manipulate code, essentially. Second, keep on practicing. It is not enough to graduate from YouTube University. Try and buy the textbooks. Try or download the textbooks. Try take courses if you can, online free courses if you can, but the point is to keep practicing. It does not matter whether the capacity for walking exists in a baby. It only matters whether the baby walks. So I would ask baby practitioners like me to keep on practicing, keep on trying. Try and solve a problem today, try and solve a problem tomorrow, try read more, and with time your understanding of the field will get more and more sophisticated to the level of expertise. It is not a lie that the secret to anything is practice. Yeah. The question of whether you're intelligent enough to do it is neither here nor there. If you have time, time is a weapon that you must use to your advantage.
Fantastic. Yeah. Thank you. So when I first did anything in machine learning, you recommended a book or it is published by O'Reilly.
Yes.
It is hands-on machine learning.
Yes.
The author is called
Aurélien Guéraud. He's French. I really am sorry for butchering your name. You will probably butcher mine.
Okay. Fair enough. Okay. Yeah. So
I would recommend that amongst many other books.
Fantastic. Actually, yeah, and you also recommended a YouTube channel.
I've forgotten the name of the YouTube channel. I'll have it in the links.
Description. Okay, yeah. So would you share with me a list of maybe some of these resources? Then we can link to them in the video. So
definitely. Yeah, definitely. Specific links to specific videos that I found very particularly useful for me.
Fantastic. Okay, so if you'd like to find out more about machine learning and artificial intelligence, like Carringtone over here, we're going to be sharing some of the resources that he recommends, so you'll have a look at it on the description of the video. Great. So this brings us to the end of the interview. So here, I would like you to just tell us any parting thoughts, parting shot about artificial intelligence in your view. Just something to wrap it up. What's on your mind?
I would tailor my message to Africa and Africa's young. In 30 or 40 years, you're going to be 40% of the population of the planet, if I'm not wrong. What do you have to offer the planet? It's not what the planet has to offer you. What value are you going to add to the planet? Our continent, our country. There is coming a time when we will be the demographic force underwriting the planet. Most human beings will either be Africans or third or fourth or fifth generation Africans in the diaspora in Brazil and the United States. What do we have to offer the world? I would really push us And this is why we have Kisima. This is why we have all these projects. To start thinking about the technological future of the planet, the technological future of the continent. And it starts here. It starts with simple conversations. It starts with us talking, trying to understand AI. It starts with us trying to get into our science books. It starts with us industrializing. What do we have to offer the planet? Is it just malls? Or is it factories of objects and factories of ideas? I leave you with that question.
Fantastic. Hey, an interview never ended better. Yeah. Thank you so much we have come to the end of the episode, and we'd like to thank Carringtone very much for sparing the time to join us today. Thank you very much.
Thank you, my pleasure, and thank you for having me. I've really enjoyed myself.
Fantastic.
It is nice to meet you as always, Roger. It is semi-nice to meet your producer, Dagi. But thank you very much for having me on a serious note. Patricia and Chris, I could not have said any better. The setup was amazing. You've treated me amazing, and I hope I have added value a little bit to the country and the continent.
No doubt. Okay, great. So for more videos like this, please like this video and subscribe to our channel, and see you next time. Peace.